Okay, here's the answers. If you hear some Scooby-Doo in the background, my kids are watching Scooby-Doo. Dalton's law of partial pressures. All gases create equal pressure under the same condition. So in this problem, if the total is 900 millimeters of mercury and the other two gases are already doing this, then 250 is what's left over, right? All right. A fixed container holds 2 moles of a gas. All right. What is the volume? All right, since we used atmospheres, we're going to use 0.0821. So we just did PivNert, and then I took the 4 down here, solve for V. There you go, 20.7. Could you tell what this was by looking at this problem? No. Any gas, 2 moles of any gas would have done the same exact thing. A weather balloon does this. Now, when it says the pressure drops when we're using kilopascals, that means that the standard pressure would be 101.3, right? So that's the only trick to this one. This is PV over T equals PV over T. To solve for V, put the 240 up there and the 77 down there. That's what you get. This is a PivNert. Now, every time you're asked what the pressure for is, if I don't tell you, just make it atmospheres. So you'll see me do that on this test. That's what I got there. PV equals nRT. Right here, same thing. Right? It asks for the pressure. So just give it to me in atmospheres. So I just use 0.0821. Notice I changed this to 306 because it's got to be in Kelvin, right? Let's see. Up here, this is a combined gas law problem, right? And it didn't give me a pressure, so again, I just put a 1 for atmospheres, so now our answer is going to be in atmospheres. The secret to this one was it gave you grams, so I converted it to moles. CH4 is methane, it weighs 16 grams. So you got 0.75, that's your N, all right? The container in this problem, I know it said 12, that was a typo. Container in that problem, if it gets hotter by 10 degrees, the pressure would end up going up. I just did PivNert again, but with 306 instead of 296. What is the phase at 1 bar and 300? That's right there. It's a liquid, number 11, because 300's right there. 12 would obviously, 12 is going to fall over here. That's a solid. 0.2 bars and 100, so 0.2 is that next dash there means 0.2. This is logarithmic, so you see the numbers crush down like that. If you don't have that in your head, you'll learn it someday. And then 13 is over here. That's a gas. Then as we move from 11 to 12, that means we go from liquid to solid. That'd be called freezing. Almost done here, people. What is the triple point? I got 0.008 bars and 260 Kelvin. So right there, so it should have been, 0.008. Almost up there. And then, is this substance? No, obviously not. It's not fresh water. How are molar solutions made? You got to add the powder first. The powder is really called a solute. Then we did a molarity problem, right? So this meant I converted 200 grams to moles. This many moles in 0.7 liters is how many moles per 1 liter? I got 4.89. 55 grams, I converted that to moles, 0.46 moles. 0.46 moles in 200 liters is how many moles per liter? That's 0.002. Now, coincidentally, you see the number 0.002 here. So for number 20, you have to say 0.002 divided by 44 because carbon dioxide weighs 44 grams per mole. So 0.002 divided by 44 gives you 0.00045, and that's how many moles would be per per liter because it's already in 1 liter of water. There you go. I hope that helped, and I know it might be a little bit fuzzy.